All right, so here we are in the middle of the first question from chapter 7, and we are going to run stat calc one variable stats on L1. And notice x bar is 1.925. Do I use sigma here? No, because it's a sample, right? The calculator calculates both. Remember, it's calculated the same way except for that denominator. For the sigma, it's divided by 8, and for the s, it's divided by 7. Right? There's a difference between sigma and s. Sigma will always be smaller, s will always be larger. So we have to use the s. Okay, so x bar is 1.925. And s is equal to, I didn't quite catch it the first time around, 0.139. And we have to standardize 1.925. How is 1.925 in relation to 2? Right, because since 2 is the assumed population mean, that's the center of our curve, right? And so how far is 1.925 away from that assumed 2? We assume that mu is 2 to show that it's false. So we're going to calculate t. We're going to say t equals x bar minus mu over s over radical n. X bar in this case is 1.925 minus 2 over 0.139 over radical 8, not radical 7. Be careful on that because you have the number 7 in your head because of the degrees of freedom. 0.139 over radical 8. That's going to be my denominator. And then I'll take 1.925 minus 2 divided by that answer. And I get a t value of negative 1.53. So what does my decision have to be? Fail to reject. I didn't get far enough away, right? I need overwhelming evidence, which means I have to be far away from 0. I was a decent amount away. Maybe if alpha had been a little larger, or maybe if it hadn't been two-tailed, right? Two-tailed splits the area up into 2 parts, so that's kind of annoying. But this would be a fail to reject the null. And what happened with the claim? I was trying to reject it, correct? Was I able to do that? No. So not enough evidence to reject the claim. Questions on number 1 from chapter 7. You've been doing this for forever now. I mean, this has probably been 6 weeks, 7 weeks on hypothesis testing. As long as you know the formula and you know the setup, you're probably pretty good to go, is my guess. Questions there? Know how to read your t-table. All right, next one. Basketball player states that he averages less than 20 points per game. You randomly watched 33 of his games. You're very passionate about this. From sample, you get a mean of 21.1 with a known population standard deviation of 6.1. Interesting. At alpha equals 0.01, can you support the claim? Notice here, you know what sigma is. However that happens. Okay, you don't know what mu is, but you do know what sigma is. That is interesting to me. But nonetheless, this is telling you you're going to use the z-test. Right? This isn't going to be a t-test. This is going to be a z-test. So you're trying to support the claim. So you're going to use that word in the interpretation. That means the claim has to go in the alternative. And its mu is less than 20. Which means the null has to be mu is greater than or equal to 20. So is this left-tailed, right-tailed, or two-tailed? Left-tailed. This is the left-tailed test. You have values far to the left. So let's see here. I'll make my curve. I'm going to find this value by doing an inverse norm command. Inverse norm 0.01 is going to be what we call the critical value. negative 2.326. So what that's saying is, remember, negative 2.326 is the boundary between top 1% to the left and not top 1%. Okay? If it's a left-tailed test and alpha is 0.01, you're saying I need to be in the top 1% of all extreme values to reject this null hypothesis. All right. If you're in the top 1%, you're willing to say, oh, I bet this isn't through mathematical chaos. I bet the null is false to begin with. Does that make sense now that we're kind of circling back and seeing this all over again? This is the top 1%. So let's see if this value of 21.1 is in the top 1% or not. Well, taking a quick glance, if you know it's not, because in fact, it's on the wrong side of the curve, right? He ended up getting with a sample mean of 21.1, which is not on the left-hand side, it's on the right-hand side. So we're actually going to be on the wrong side of the curve here, but let's just go ahead and, of course, finish it off, but it's not going to work out very well. Z equals x bar minus mu over sigma over radical n, because we know sigma, we can use the z test. X bar was 21.1, mu was 20, over 6.1 is sigma over radical 33. Let's calculate that value. My denominator is going to be 1.06, and I'll take, well, 21 minus 20 is 1.1 divided by that mess. Gets me a z value of 1.04, which is way over here, right? You're obviously not going to be able to support that claim if he got averaged more than 20 when he claimed that he got less than 20, okay? So that's going to be a big time fail to reject the null. Not enough to support the claim. What do you think? Question on that? We're good? Question? We're happy? Almost there? Almost there. No one's looking forward to 2 weeks off more than this guy. All right, here we go. Randomly select a few stocks and get the data below. Can you support the claim that there's a positive linear correlation between X and Y? Now we're in chapter 9 stuff with rho. Remember, rho is your population correlation coefficient. So let's talk null and alternative first. Again, trying to support the claim, so the claim must go in the alternative. What does it mean in symbols? How do we write positive linear correlation? You know how that works. Yeah. Rho is greater than 0. Okay, remember when rho equals 0, that means there's no correlation. If rho is greater than 0, that means there's a positive correlation. If rho is less than 0, it means there's a negative correlation. So this is going to be rho is greater than 0. It's a real fancy P, and that's going to be the claim, which means the null is rho is less than or equal to 0. So you're starting out with the assumption that if there's either no linear correlation, or if there is, it's negative. And we're assuming that so that we can show it's positive. Right? We have to assume the exact opposite to show that the alternative is true. So we're going to assume that there's no correlation or that there's negative correlation in order to show that there's a positive correlation. Makes sense. This is what we always do. Let's see. We get degrees of freedom. I think in this case it's n minus 2, isn't it? 1, 2, 3, 4, 5, 6. I think degrees of freedom is n minus 2, which is 4. Am I right on that one? It's been a while. Okay. And it's going to be a right-tailed test. So I get my T curve. I'm going to grab the table here. 4 degrees of freedom, 0.05, one-tailed test, 2.132, I reckon. And here to calculate t, it's a t-test. It's r over the square root of 1 minus r squared over n minus 2. My memory holds. So we have to calculate r. But of course, with the calculator do that. We don't do it on our own. So let's go to the calculator here. Earnings per share, 0.96, 1.21, 0.54, negative 0.3. Ooh, they're losing money. 0.21, 2.21. And then the Y's are 15.43, 47.86, 12.9, 18.42, 10.21, and 96.97. For all of you stock market watchers out there, let's go stat calc lin reg L1 comma L2. All right, we're running a linear regression here. And we get an R value of 0.86585. If that's not coming up, you need to turn your diagnostics on. Second 0, go down to the D, enter, turns your diagnostic on. If you had to reset your calculator recently, maybe that wasn't working now because it probably should have been working when you took this test. But if you had to reset it recently, maybe you have to get those diagnostics on. If there's an issue during the test, just let me know. But make sure to, if you have not done so, go to second catalog, which is second 0, and then go down to the D's and make sure your diagnostics are on. So we get R is 0.866, let's call it that. And minus 2 is 4. I'm not going to do this in one fell swoop. I'm going to do it in parts. So there's the numerator of the denominator. Divide that by 4. And then square root it. And then 0.866 over that denominator. Gets me 3.46. Whee! All the way over there. So this would be a reject the null. And enough to support the claim. Any questions on hypothesis testing for linear regression for correlation coefficient? We're happy. Gabe, questions? No, you're all right. You remember it. Or it all makes sense. It makes sense. You see the formula, you can do it. Sure, Tom.
Are these, for like the linear correlation, are these always t-tests?
Yes. Unless the one case happens where it's two-tailed and alpha is either 0.01 or 0.05, then you can do that. One special table, table 10 or table 11, something like that. I don't think that's how it's going to work out Tuesday, tomorrow. All right, here we go. Find the equation of the regression line. Not too bad. We like how this works. You're not testing whether the correlation is significant. You're just finding the regression. So I'm going to go to my table here, 7, 15, 23, 34, 50, and 28. And 14, 10, 4, negative 3, negative 5, negative 5. Stat calc one variable, oh, it's not that one variable, so that's linear regression. L1 comma L2. And we get y equals negative 0.48 x plus 15.05.
Hey, Mr. Marco.
Yes.
We do that exact same thing on our calc exam.
Is that right? Greg should be an expert.
I know. Isn't that funny? It's in our review chapter 1.
I'm so excited.
She knows what she's
She's not, there's not a lot of confidence over here, Elaborate.
No.
There's not a lot of confidence. It's okay.
He's agreeing.
It's okay. All right, let's see. Y equals, what was it again? Negative 0.48, is that right? X plus 15.05. And then it says if X is 20, predict Y. Well, all we do is plug in 20 for X. So negative 0.48 times 20 plus 15.05. Duke. I get 5.45. And then notice it says if Y equals 6, so now we're replacing Y with 6, not X with 6. Because sometimes you want to know what X value would give me this Y value. So I'm going to say 6 equals negative 0.48X plus 15.05. And it turns into an Algebra 1 question. Subtract 15.05. So was that negative 9.05, I guess? And then divide by negative 0.48. X is 18.85. If you look at that data, it makes sense. Somewhere between here and here. Seems reasonable. Questions on regression, predictions, that kind of stuff. I think we got one more to go. Chi-squared. Issues. We're happy. All right. Last one. Are you ready to cry? Let the record show, if you're watching this video, that we have 17 students in tears right now. Remember this day. This is the greatest day of your career, Mr. Marco. All the students are crying. That's on the internet forever. No, it's okay. Do you want a tissue?
I'm good, honestly.
Oh, she's just trying to act tough.
This is the last math I ever have to take, so.
Oh, no.
I'm pretty happy.
Oh, no. But what happens when you get a mortgage? Or what happens when you want to start a Roth IRA?
You too.
Do those one variable stack.
Yeah.
What about credit cards? Everywhere. Everywhere. All right, here we go. Mr. Barkle claims the distribution for grades in the geometry courses is as follows. 15% A, 15% B, 30% C.
Let the record show that's
35% D and 5% F. Ugh.
That is on the video.
Yeah, it is. I randomly sample 200 students, and I get the following letter distribution. Can I reject the claim at 0.1? Well, let's see. If we're trying to reject it, that must be the null, right? So the null is distribution as claimed. This is that chi-squared goodness of fit test. And the alternative is going to be the distribution is different. Okay. It's the chi-squared test. Degrees of freedom is k minus 1. And k is the number of categories. And in this case, there are 5 categories, so the degrees of freedom is going to be 4. And remember, the chi-squared goodness of fit test is always right-tailed. And the table is always red area to the right, so it works out nicely. So I'm going to go to degrees of freedom 4, alpha is 0.1. I get, and that's the t-table. I was going to say, that doesn't look right. All right, degrees of freedom 4, alpha 0.1. I'm getting 7.779 as my boundary between the top 10% and the not top 10%. And recall here, we have to calculate all of the expected frequencies. This is a comparison between what we observe and what we expect, because we assume the null is true going in to show it's false. And so what we say here is, well, let's calculate what we would have expected to happen if this is exactly correct. And so what we do is we calculate these expected frequencies by taking the sample size times the given probability for that index, for that category. Okay. So for A's, if there's 15% in theory of 200, we would expect 30 A's, correct? Same thing for B's, we'd expect 30. For C's, we'd expect 60. For D's, we'd expect 70. And for F's, we'd expect 10. Those are called the expected frequencies. The farther O and E get away from each other, the more evidence you have that the null is false. Right? That's why it's always right-tailed. And then recall, we use our calculator for this. So we go to our list 1. And I go, let's go observed in this column. So it's 16, 38, 79. It's not looking real good for me. 52 and 15. That's the observed column. Here's the expected column, 30, 30, 60, 70, and 10. There's a good amount of difference here, especially with the A's and the F's, quite frankly. I mean, that's 50% off. So let's see what happens. I'm going to go over here to L3. And if you recall, chi-squared is the sum of O minus E squared over E. So I have to calculate list 3 and then do the sum. The one variable stats on list 3, look for the sum. So I go L3, I go up here to the L3, it's in black. I hit enter, and then the cursor starts blinking. And I say parenthesis L1 minus L2 observed minus expected squared divided by expected, which is L2. And I hit enter, and all of those cells populate automatically for me, which is fantastic. And then I have to calculate the sum of all of these values in list 3. Stat calc, one variable stats L3. We get a sum of 21.8, which is way over there, right? So here I'm going to reject the null. And we'll say enough evidence to reject the claim. Let's face it, you learned a lot in 16 weeks, didn't you, or 18 weeks? You'd walked in here day one, and I did all these things, you'd be like, oh my goodness. You learned a lot. You should be proud of yourselves. You did good. That's it. I will post the video under Monday evening. Exam tomorrow. Rock them. Good luck. Bring your tables. And your calculator.
What?